Okay, so I guess we can get started with the lab work. Estimate the quantity and cost of the cold and hot water lines in men's room. Is there any volunteer that would like to do this first section? No? Come on, guys. No? Oh,
Is it going to be
God.
Is it going to be done by fixture, or are you going to have to go to the riser diagram and the?
Well, yeah. Normally, what we will do is we'll find the isometric drawing for plumbing. So here is all the plumbing drawings. It starts with P. So we'll go to P1 and then see what information we have there, right? So P1 gives us the plan layout, and then we'll see, there is areas over here that covers the men's room. There's additional restroom in this corner, mechanical room, and then we have some piping over here, right? This is the sanitary line that goes to the waste outside. Then we have over here another area with piping. So there is some in the storage room. The air handling unit 5 is located here. Air handling unit 4 is located here. Air handling unit 2 is located here. What normally happens is that you need to have a drain on each one of those air handling units, because an air handling unit is just a coil, right? It has refrigerant on it, and then this refrigerant comes in very cold. So you have air that goes through that coil. So it goes from one temperature to another one. This is normally colder than the air that comes in. So this air has moisture. It's a combination of water and air. So when it goes through the cooling coil, that cooling coil it's at a temperature below the dew point of the air. So that some of that water that is going through is going to condensate on the cooling coil. So it's going to create water. Okay, it's going to accumulate water in a pan, and that water is drained to the sewer system. So you need to collect that drain, and that's why you're going to see that there is a line that goes to each one of these air handling units. Okay. Then, of course, you have the restrooms that have water that's coming from the sinks and from the water closets, and you need to collect that water. So they normally they will tell you what is the diameter of the pipe. This is 3/4, 1/2, and you need to read the notes to be familiar with what material they're using, or what is the usage of that line. Here we have a water heater. So the water comes in from the main supply, and then it's distributed to the different places as hot water. So you will need hot water in the sinks, and depending on where they have it, if they have a shower, you will need hot water in that shower. The rest will be just cold water. So we have this plan layout here that shows, about how the pipe runs. The other thing to take into consideration that this is mostly for diagram purposes. The line is not going to go exactly over here. It may go rather close to the wall, because that's where you can have hangers. So you can have, you can hang your pipe in a location that is convenient. So this is mostly to show you, what type of pipes you have, what diameter they are, and gives you an idea of what's going on. The other thing with these pipes is that, remember we talked about two different systems. One is pressurized water, and the other one works with gravity. The drain vent system works with gravity. So what happens is that you need to have ventilations that go all the way to the roof for this system to work. It's like when you have a straw, you put it into water and you hold the end, the water doesn't move because it creates a small vacuum over there. So you need to vent that out in order for the water to move. Same thing, same principle goes with the wastewater system. So you need to have vents. Those vents are vertical, so you cannot see those from the plan layout. You need to look at the side view, estimate the height, and then count how many of those points you have. Additionally, we have also the problem that when you come out of a water closet, for example, that water is going to move by gravity, right? So if your pipe is horizontal, where do you think that water is going? Nowhere, right? So you need to have certain inclination for the gravity to pull that water down. But when you see the drawing from the top, you can't really see the inclination, right? So you need to include in the software this slope, right? When you see this from the side, you will see a line that is inclined. When you see this from the top, all you see is a horizontal. It's a line, a straight line. So if you tell the software what this slope is, it's going to do the calculation for this line given this one and the slope. Okay? So that's what it will do. Is that clear? All right. So then we have this other drawing. This is for the kitchen. And then see, we have some plumbing connection schedule. So it will tell you location, the description, the pipe size, and then there is a number here associated with it. So you know, gotta sort of be familiar with the drawing and read all these notes, right? Okay. This is another one. This goes to kitchen water, and then it has some has a list of equipment. So you have mop sink, vegetable preparation sink, combination oven. This is also useful because you can sort of think about what type of utilities you need. Every time you see sink, most likely you will have at least cold water and then a drain point. So that's something to consider and go check. Then we have these isometric drawings. These it's sort of a non-to-scale drawing that shows you how the system works. So here we see, I think we have, this will be the main hot water line, goes into the water heater, and then starts branching out to the different points of use. So you need to sort of understand where are your points of use, how to relate those to the plan layout, and then here you see that there are some pieces of pipe that has different heights. What I used to do is instead of going and calculate each one of those, you know, separate and try to be exactly accurate about how high they are, is I will look at the height of the building and I will say, okay, that's my worst case scenario, multiply by the number of rises that I have, and I'm done. So I will end up with a little bit more piping, but the cost of that extra piping is worth. it's better than spending my time calculating that to the exact number and then end up being short. So that would be really a disaster. So, you know, that's one way to do it. So that's the cold and hot water piping isometric. We have another isometric over here. This is a gas line. So basically, you know, the pipe goes out of here. We have a pressure regulator, some valves. The piping goes and gets distributed to these 2 point of uses. This one has a loop, and you know, that's pretty much what it is. And you have one valve at each one of the point of uses. Okay, so basically each one of these lines represents a pipe, and then it will tell you what is the diameter of that pipe, and you know, it shows typical arrangement for valves and so on. Then, you know, if you do get into, yes.
I have a question. The type of pipes and the diameters of the size of the pipes, is there come included in the plan?
It should be in the notes. Yes, it should be in the notes somewhere.
But how about if you find, let's say that you find online or your research is a cheaper or a better pipe than the one is on the notes? Would you be able to suggest that to make changes, or once it's written
It depends. It depends on what is your contract with the owner. You know, if you have the capability to suggest different materials, different types, then you can. When I was working for Quaker Oats, I mean, I was doing a system for them. They have specifications on certain pipes that they will not change because it was a specialized use. And then there were others where they didn't care. As long as the system works, that's fine with them. So you will buy the cheapest one, or one that you think that will last the longer, or the one that has the least amount of maintenance associated with it. You know, that kind of thing. Okay. So that's about reading the isometrics, looking at the layout. Here is toilet rooms, the kitchen. Oh, what I was going to say before, it's if you are, you know, by any chance really having to develop one of these, a quote for this, or have to do an installation, then you will get into a lot more details. You will have to estimate the number of fixtures that you have. Like, for example, here will be a Y, so it's a piece of pipe that has a connection on the side and it merges two lines. You will have to have elbows on these points where you go either up or side or change of directions. You need an elbow over there. You will have a valve at each one of the point of uses, so you can close the pressurized line and do maintenance on the unit if you need to. But you know, for the purpose of this course, I am not going to be so picky. You know, I don't think you guys are going to be in one specific trade. I'd rather give you the overview so you can do anything, and then when you're working on your field, you will use whatever you need. And here, see, there's plumbing specifications on this drawing. Very likely, it's going to say what type of piping you need. For example, here, sanitary waste vent and storm piping shall be centrifugal cast iron. So, you know, this pipe is going to be cast iron. Condensate drains shall be copper below ground. Potable water below ground shall be type K, hard copper. This is copper then. Pipe support should be compatible with piping insulation. There is a note for PVC here. Oh, here, no PVC shall be used in return air plenums. So, you know, it gives you a specification in what type of material you need to use. And I know it's cumbersome to read all this stuff, but it's important to do it so you get, you know, the items correct. Here is connection schedule, so it tells you what are the marks, WC1, water closet, and then it tells you what type of water closet it is. The waste line is 4 inch, the cold water coming in is 1 inch, and there is no hot water. And the counter sink, you have 1¼ inch waste and then ½ inch both for cold water and hot water. So it gives you a schedule of connections. And then here is the legend for plumbing. So you have standard sanitary line, storm drain pipe, vents, cold water, hot water, the different type of valves that you may have, the P-trap. We talked about the P-trap before, right? Yeah. Clean out points, ventilation. So if you read these notes, you will get very familiar with what's going on. Here is a detail of the condensate trap. This is a little bit different from the regular traps that we will have on the sink. This is the one that comes from the air handling unit. So after you collect the water on that pan, it has a little design over there. So you have a point for cleanup. This is very important because what happens is that in this line you can get algae form, you can have blocks, and what happened over time is this line gets clogged. And when that happens, this drain pan is going, where do you think the water is going to be? Down on the floor, right? So then you get a leak where the air conditioning is, and problems start, and nobody knows what it is. So you need to have a clean out. You take that off, you put some bleach on it, or you put hot water, or whatever you want, and then you clean that pipe, and it should be fine. Ventilation line. Sometimes these drain pans will also have a water detector. It's a small connection with two cables that goes into the air handling unit. So if it detects that there is an accumulation of water here, meaning that this line is blocked, it will shut down the AC. So then you have no choice but to do some maintenance on it, right?